So we're back again, and the usual reminder: if you look at the look at the video on YouTube, down below, if you open up the description, it'll have links to our big indexes that I created, and it'll have a link to our YouTube channel and maybe a link to our Slack channel and some other fun stuff down there, so you can go look through that stuff. And again, one of these days, I just make up a separate video that says, here's how I use the index stuff, and this is why it's done, and show all this stuff. But right at the moment, I don't have that. I just kind of just on a weekly basis, just kind of keep piecing it together, and it gets bigger and hopefully better as I do that. So let's see, what did I do this week? So one of the things was Al was showing some high power RGB LEDs that he ordered, and I went out to that same website, and let me share this. Share screen. Come on, do something. Display one. And if I look at my outgoing feed, which of course disappears, so I can't see it now. Are you seeing a page with LEDs on it?
Yep.
Last purchase September 20th.
Okay, so I noticed what I was looking at. If you look down here, it's got all these different options you can order, and the one that Al had ordered, or Al ordered, must have been this one. No, 4.
I thought it was the left one, the 1 watt one.
Okay, see, there's a trick here. This is actually, this says 4 chips in this one. This is red, green, blue, and white inside of this one. That's what I ordered. So for $2 more, I got an extra chip, which cuts down on the wiring. And which one is that? And there's something else I was noticing. I hadn't noticed this before, but you go look at these things. Are they just in a weird order here? Why it has changed since the last few days I looked at it. So anyway, he ordered some that was is an RGB, and they were 1 watt LEDs inside of it. And it's probably not going to show me that. Let's see, 5 pieces, 3 watt, 5 watt iron. It's an IR. So I was also noticing, because when he presented it last week, I just did a search and I popped up the one that said $9.99 for 5, and then also there's one that said $8.99 for 5. When I went back to look at them a couple of days later, I only found the one listing, and that was this one that I'm looking at right now, and it had about 10 different options here. So they had all kinds of different things, but you got to be careful now, because it'll say, this says 5 pieces, 1 watt. This is the one. This is the one.
Yeah, that's what I think that's the one I think I have.
So Al ordered this up, and he got 5 pieces, and it's RGB, and they have this separate, because you can also get it on the chip here. You can get either the separate wires coming out, and this is what they call a 6 lead LED. And then you have the option of wiring each one in either series or parallel with other LEDs. And the ones I had originally were the 3 lead. I don't know if those will show up here. Nope. Come on, do something. Oh, now my thing doesn't want to display correctly. Anyway, the ones I had originally, and I'm sure you won't be able to see them, but here's this one. The LED has 4 pins coming off it instead of 6 pins, which means you order it so either the anodes are tied together or the cathodes are tied together. So on mine, I got a common anode, and I got like 12 volts connected to that pin, and then I got the RG and B coming off, and I was controlling those in order to run the thing. So let's come back here and finish off my story here. So this is I ordered up this one, and it's now an 8 lead LED.
Good
and if you look at it, it's got inside, you can see it's got 4 chips in there, and the red one's obvious, and the one that looks yellow is actually the white one. So the other 2, one is red and one is green. And hopefully, yeah, that's enough leads. I say it doesn't have enough pads out here, but yeah, it's got a total of 8 pads on that you can solder onto. Let's see how to get that back. So I ordered those and they're laying here. I haven't done anything with them other than I poked at them with my voltmeter to light them up so I can say, yeah, they do work. And I haven't soldered any wires on it. And so that I just want to point out I bought those, and I could go back and redo my box. It's on top of my robot right now. And in fact,
So
here,
you have pads that look like perfect squares, and then you have pads in that image on the left and the right that are more like rectangles. Are those duplicate ways to connect that up? Is that what that is?
what you're talking about on this picture of the LED right here that we're looking at?
Yeah.
The small pads are just simply so you can solder the LED down to the board, and that holds it down. And it's got the big pads you can solder wires on. And it turns out those are connected somehow internally, so you can solder the wires onto those big pads there. Let's see, why did I do that? I want to do this. I want to do this. I was
So
gonna
is there an advantage to using the square pads versus the rectangular ones? Or do you have
uh,
to use the square pads?
on you could use either, but it's just a pain because those are little tiny pins that are for the LED itself. And what I did, the one I'm pointing at right now, I think I soldered those right onto the LED. And my cable isn't long. That's all the closer I can get to it. But that's my metal box that it's got the black one on there is the orange LED, and the white one is the RGB LED. And that's just duplicated 4 times, around there. So that's how I did originally. And if I put this new one in that's got the red, green, blue, and white, if I don't care if my thing is white or orange, then I could just switch over that way. It would save that much wiring, and I would have fewer physical LEDs on the thing. So anyway, let me go back to here. This wasn't real convenient to do this, but that's the way it just worked out. So let's see. So that was the point. I ordered those, and those showed up. And then I was looking into current source drivers for these devices, and I ended up ordering this one, which single board looks like. Of course, they're not going to show you a single board. Come here and zoom in there. So see, this is actually 5 boards that are panelized together, and they scored them. So if you want to, you can snap these apart. And I thought it'd be easier to mount them if I leave them like this. So if I just either glue this to a piece of plastic or glue it to some popsicle sticks or something.
You're not
Um,
sharing, by the way.
sharing. And come back here.
Now you are.
There. Now it says I am. So if again, looking at the front of it, a single board looks like that. And see there's 5 of them on there. You can snap those apart if you want to. And it turns out these are very simple things. You put in oh, that's what I was going to do before. I was going to look up the video where they're talking about this. But anyway, you put in your power, and it has to be like 2.9 to 6 volts. And then when I first looked at it, I thought, well, that's not what I'm looking for. So I was ignoring these. But then I later came back and said, well, this might be what I want. So you put in power, and you hook up your LED, and you hook up the ground, and then you turn. There's a little tiny microscopic pot on the thing that I don't have a screwdriver that fits that, so that was another problem. But you just turn that and adjust the amount of current you want, and everybody's happy at that point. And if you look at the back of the board, I just saw a picture. This is what the back of the board looks like, and there's like just a big copper pad back there and a bunch of vias. So the chip is supposed to conduct heat through the board. That might be the reason why I don't want to glue it down to something, because that would restrict any airflow on the back. I could go ahead and solder pins on, so it's just got normal holes with pads there. I could solder pins on there and stick it into a proto board, stick it into a perf board or whatever, and that would give you a little more airflow on that. So anyway, I got to the point yesterday when I took my LEDs, and here's one here. If I say stop sharing, and you probably won't be able to see this, but it's just back to the question about where do you solder wires on the thing. Well, here's an example of this. Happens to be a white LED, and I'm sure it's not going to focus here. Come on, come on. Shove it down your throat if you don't play the game. So anyway, that's not going to focus. If I back off, it probably will. So it just got, a 2 lead LED soldered down to this board. And you can see, back to Al's question about what do you solder onto it? Well, you could solder onto the two pads coming off the LED, and then I've got the square pads on there. So I just soldered the wires onto the square pads. And I did this so I could now just quickly interchange these. And I was using just using a little miniature proto board. That's about an inch or an inch and a quarter long. That's just a way to just join all this stuff together. So on the little board, I just soldered my 4 wires on there and plug them into there. And then I got two LEDs on there. One's right now, one's a red and one's an orange. And it turns out those both run at the same voltage. So I put them in parallel for experimentation. And I started off with the orange one because the orange one is a 3-watt LED that they mistakenly sent me when I ordered a 1-watt. So I thought that would give me some margin as I'm playing around with it. If I overshoot on the current, not knowing how well that pot's going to work on the board, if I overshoot, it'll go up to 700 milliamps, and everybody should still be happy. I was gonna say, what am I sharing? I guess I'm not sharing anything. That's good. That's where I want to be right now. So I had the 2 LEDs, and the red and the orange should work exactly the same. It's just that I can put twice as much current through the orange one. So I thought that would be a good way to test it out and not blow anything up. And I hooked it up to a bench supply, and just I could dial my voltage up and down, and I could see the current running. And I put my digital voltmeter in series with the LED so I could see what the current was on that one. And being a linear or an analog device, the current in equals the current out. Now, if you have a switching board, that's not the same. But for right now, I can see I dialed it up and I got around 280 milliamps. And I could see that on my bench supply, and I could see it on the voltmeter. So both of them, that agreed right there. And that I thought that was going to be the case. And that proved that, yes, that is what's happening on that. And something odd, I've got this set up like this, and sitting on the table there, if I put my finger on the thing, the lights the LEDs start flickering. In fact, if I put my finger there, and then the LEDs go off completely. And I'm not sure why it's doing that. I don't know if it's capacitance or it's picking up noise or what it's doing, but that's something odd that I didn't expect. But in general, these are easy to hook up. You just hook your LED to the board and then hook up your 2.9 to 6 volts into it. And since that's not what you typically are going to have, like Al would probably prefer to connect this right to his battery on his electrical system, so he's getting like 12 to 14 volts coming into it. But I thought, well, this will still work. It's just that being the analog parts, you don't have the switching circuit in there, so you don't get the efficient transfer from the high voltage down to the low voltage. And I thought, well, what you could do is, let me here. Do I have it on the screen here? No. Okay. So let me just pop up one of these and say share screen. But if you just go out to Amazon and grab one of their little random switching converter boards like this. So this board, you can put your battery voltage into it, and it's got a pot in there. You can adjust it up and down. And so basically you just adjust that for the voltage you want. And this will do the efficient power conversion. So it takes your battery voltage of 12 to 14 volts and convert it down to, say, 5 volts. And then you've got that pot, so you can run that up and down a little bit, to tweak it in to get your maximum efficiency off the thing. And there's various ones here that, you can buy the different flavors. This one happens to be a 3-amp because of the converter chip that's on it. And you can get another one with, I think it's a 4015 chip, and it'll put out 5 amps. But basically they just have an adjustment on here, and you put in a higher voltage and you get out a lower voltage, and you can set it with the pot. And the other thing I was thinking about, I was wondering about running one of these to directly control the LEDs. And this one is not a constant current module. You can get one that looks like this. It has an extra pot and some more stuff on the board. So you can get one of these that could directly drive an LED by just setting the current level that you want. And it turns out on this one, if you look at that chip there, the big 5-pin chip, the pin on the right at that point. That's the enable pin. And they just always solder that to ground, so it's always enabled. And I theorized that you might be able to put, say, a logic signal into that and turn these boards on and off. And I looked on YouTube, and sure enough, I found 2 or 3 videos where people saying, "Yep, you can do that. You just lift that pin up, and then I think they were using they put a 10K resistor from the pin back down to the pad on the bottom, and they just ran a piece of wire off the side, and they were showing that they had one guy was showing a switch. You just turn the switch on and off, and yes, the output of the converter turns on and off. And I think somebody else showed it going to a microcontroller and turning that on and off. Because my thought was, if you turn that on and off fast enough, you might be able to get, and it had an LED that you'd be able to get the control the intensity of the LED. But I think the fact that it's got a big capacitor on the output over here, I don't think that's going to work. And the more I thought about it, I thought, well, you're probably better off getting a chip that's designed specifically to control the LED and not try to get cute like I was thinking about doing right here. So back to let's see how to get back there. Everything's on top again. Let me move this over here. So back to this board, and I've got a video on this board. I intended to have that pulled up, but I don't right now, so I'll have to track that down. But a guy goes through and does a really good job of analyzing these, and he's got basically a proto board on his table. He's got one of these modules plugged in with a 1-watt LED, and then he's got a little module that he bought on Amazon that it's the INA 219, and that will measure current and voltage. So he had that hooked up into a circuit, and then on his screen over on the right, he's got a little window that pops up so you can see it's printing out things like voltage and current, and I don't know, he's printing out like 4 or 5 things that are coming out of that chip. So at first I thought he was doing that so he could put it up on his oscilloscope display, but that's not what he's doing. He just had a little thing so you could see the numbers, and he'd say, okay, now watch, I'm going to turn the voltage down so you can watch those numbers changing, and he would run the voltage. He had a white LED on it, so it would have required around 3 volts to run the thing. And he started off by putting 6 volts into this with his benchtop supply, and he had an oscilloscope screen running so you could see, what the voltages and currents were doing. And he says, okay, now as I start backing off the power supply, you can see the LED would maintain a constant current. And he had a range, he'd go from like 6 volts down to about 4 volts, I think. And his LED would still do what it's supposed to. And that's the point right there. You can also, since you have that external supply, you can go tweak the voltage and run it down so you're get down to the point where it's ready to drop out, but not quite. And then everything will just be much more efficient because you're not wasting any extra voltage dropped across this chip is going to be wasted as heat. So that's not so that gives you by combining those 2 things together, so you get the little power supply module and then this little driver module, that should allow you to connect it directly to your battery. And it's got a PWM input on here. It's got that CE on the chip right there. That's handy. Anyway, the CE input pin lets you control. It actually switches the output on and off. And if I can find that video, he goes through all that and shows you that it's doing that. So it seems like this will do everything that I would need to do. The only problem is, since I have 4 LEDs on my thing, I have to drive all 4 of them, say all 4 red or all 4 green or whatever. And since the output only goes up to 6 volts, that means I have to put the LEDs in parallel in order to do that. So it just means I have to crank this up to 4 times the amount of current that I want, and then it spreads out over the 4 LEDs at that point. And I did notice that when this is running, I didn't run it for very long, but I fired it up. It was probably putting 6 volts into the thing. And I noticed I could feel the LED, both the front and the back. It's on that aluminum plate. And I put, it felt warm by putting my fingers on it. And this chip was warming up to the point where it wasn't enough to instantly burn me, but it was getting uncomfortably warm for my finger. So it's just a matter of, you'd have to look at the spec sheet and say, what, how much current do they allow? Now, I assume if I have it generate 4 times the current that that one LED wants. It could be that chip's going to get hot enough that it doesn't want to put up with that. So that's just more stuff I'd have to play with and experiment with on that. Another other thing that occurred to me was doing this because I found my box of LEDs. That's where my high power LEDs were. I just wondered, has anybody tried just taking a modern LED, say a red or a blue or a green, and just put the recommended current through it and see if that's visible outside? It could be that just a normal LED, um, not the little one, not the addressable ones on a strip like Al tried, but just take a regular LED and put power through it and see if it, check to see if that's visible. But one problem is the LED, the way it's molded, the lens on it, it's going to have a fairly narrow beam coming out of the thing. So it like these kind here, which let's see, I'm sharing, right? So you can't see that anyway. If I stop sharing, but something like this, because of it's got the short lens sticking up on the thing. They claim these are like 120 degrees of field of view. So whether you're looking straight into it like that or you're looking into it like that, you can still see enough light coming out of it that might be just fine. But just a normal LED has got the big long the long clear plastic on it, and that forms your lens. And those are down like 15 or 20 degrees or something is where you get the most light coming out. So maybe that number one, that would make it easier to see if you're looking directly into it, but then you're off to one side or the other. The intensity is going to go down quickly. But anyway, that's just something that occurred to me that I haven't, I didn't explore that, but I got a whole box of these. I would call relatively modern LEDs. That's when, like 10 years ago or whenever it was, they stopped selling the ones that put out like 100 millicandela, and the new ones were either 3,000 or 5,000 millicandela. And you go look at them now, they're going to brag that they're going to say, "Oh, these are strong enough to blind you now." And I don't even know. And it's something about, they had a technology change, I think, in there, where originally I was thinking the red ones were like gallium arsenide, and then somebody said, "Oh, then they switched over like gallium nitrate or something," and apparently that's why they had this big jump in intensity off these LEDs. So anyway, that's something that occurred to me. I was looking at all my LEDs piled up there. I thought, somebody should look into that too one of these days. And it could be that if it is bright enough looking directly into it, and they're small enough and cheap enough, you could put a whole ring of them, put like 10 of them or whatever to so you can see it from the different angles. So that's something else that somebody gets bored, you could try that out. So let's see, that was that. And when we get going here, I'll when somebody else starts talking, I'll do a search for that video because I know I have that somewhere. And the guy's name is Grug or Grug, Grug, and he's a different last name too than I would expect. But anyway, as I say, he does a really great job of going through this. And he's got this other box hooked up. It's like a digital oscilloscope that's, I think, from Analog Devices or something. And he shows like four different traces on the screen, and some of those are reading directly off the voltages and currents of his board. And then he's got that thing on the side where he's got the extra currents and voltages he can show. And then the whole time he's got a little inset down in the lower right hand corner where you can see he's got a camera watching his breadboard, and you can see his LED is lit up. So it works out really well, and he explains it all really well. So when we get going, I'll go search that up. So let's see, I looked at this one.
Do you mind pulling up your um, power supply thing that had the CE pin that you said was for PWM signal?
Screen. The screen.
I mean, my question is, I don't understand this stuff, and so if you put a PWM signal on that CE pin, is the voltage going to change or the current going to change?
It actually just turns the thing on and off. So if you watch it, you can see the output will be a square wave. And on his video, he says, we'll set it to 10%. And you can see that it just puts up little, you can see that waveform on the output. So this is nice because you can go in and you can set the current either by turning the pot, or somewhere it says, oh, if you want, you can just put a resistor instead of the pot. So you just calculate out the current. And the example somewhere it said, if you want 180 milliamps, you use an 18K resistor instead of the combination of this pot and this resistor that's on here. So basically, this is nice because you can put it on there and adjust the current up and down to get it to look like you want. And then the PWM should adjust it between 0 and 100% up to that level. So you're still controlling the current by the pot, and then the PWM, it gives you a duty cycle as you know when it's on and off. So that it seems like this one will work. And then the next thing that came up was,
So if you decide you're not going to be able to take one LED and make it red, yellow, and green, you're going to say, this is my green LED, and you're going to use this to turn it, the green off and on. Is that,
yeah, so
do I have it right?
each color of LED will have one of these boards on it, which is basically what I'm doing on my robot right now, except that I just got a giant resistor and a MOSFET that's doing it. So here you can just have, so, and that's also why it was nice that these boards, they came stuck together like this. And I just figured it might be easier to mount everything like this. And if I had, say four LEDs, then I just have 4 driver boards all stuck together like this. And then you just have, so one would be for red, one would be green, one would be blue, and one would be white or orange, depending which way I end up doing that. So yes, that's the way that works. And again, if we get that video pulled up, it'll make a lot more sense.
And then
And then
you would consume 4 PWM pins in order to do that.
yes, and if you
Got
wanted
it.
to, you don't have to do PWM. You can just have a digital signal, say it's either on or it's off. If you just want the thing to flash, you could do that.
Got it.
Which also comes back to the fact if you're driving, well, if you're getting a converter board that's taking your battery voltage and converts it down and is able to run your LED, theoretically you could put some kind of a switch in front of that, either a relay or a MOSFET, and just turn that whole switching board on and off, and probably get the LED to flash. If you're not trying to control the intensity from your computer, you could probably do that. And that's something I theorize, but I decide, well, I really don't care. I'm gonna just go with this concept of getting a board that's meant to do the job. So then I found this board, and it turns out it will.
Hey, you got one of those too.
What's that?
I said I saw last purchase 20 September.
Oh yeah, and the problem is I can't find these in the United States. I can find them both on eBay and on Amazon. There's tons of them in China. So I ended up, let's see, what does this say? I think it said 10. Oh, that's real handy. What did I do there? Yeah, I got 10 pieces for $11, but I had to pay $5.70 shipping. And so that puts it up around what, 16, up around $16. And for 10 of them, that's like $1.67 a piece for these boards. But it's going to be, it says it's purchased on the 20th, and it says the delivery is October 8th, or no, it says September 30th to October 8th. So it's going to be, 2 or 3 weeks for it to show up.
That's coming directly from China.
Yes, they are. In fact, after a couple of days, it says, "Oh, your package just left this shipping center in." It wasn't Shenzhen, China, but it was somewhere around that area. Let's try this. Go. Okay, zoom in on this one. Now this combines your switching regulator and the LED control. So this one you can put up to like 26 volts or 30 some volts into it, and it's got your inductor and all the parts on there to make a down converter. And then this also has a PWM pin on it. And it turns out I found a video on YouTube. A guy also had one of these that he was playing with. Let's see, I should think about this a lot harder. Is that, yeah, I'm still sharing that, right? So
Yes.
this is, now with my giant screen, I have to keep remembering, oh, it looks good on my screen, but when I put it on the video, it looks too small. So anyway, here's, can I zoom in on this? Well, let's try this. I'm probably going to screw this all up here.
There's a zoom button there to the top right.
Yeah, I think it. Well, anyway, that's what the board looks like. It's got a just a little switching converter chip, And this one does not have adjustable current. So I think of these three resistors here, I think if you knew what you're doing, you could pop off at least one of those and replace it with something different and get this to run at, so you'd set the current that way. And then I think the PWM pin works just like that previous board. So you either, and this one's backwards. If you set it low, the LED's on. If you set it high, the LED goes off, which means if you run a PWM, it's going to be backwards. So you say, at zero, the thing will be on, and then at 100% it would be off, and at 50% it would show up like you want. So it's just the response curve is backwards. And I he didn't go very far in his video. He got to the point he say, okay, here's my voltages and currents. And then he said, let's give it something. It took his tweezers. Everybody always uses their metal tweezers while they got these live circuits that doing their demos. He stuck his tweezers into those two pins and say, well, shorten those together doesn't do anything. So he pulled up a battery and a resistor and poked the PWM pin with the resistor, and the thing just turned off. So he'd move it on. He said, oh, so you could PWM that, but he never did. So I don't know, how the response on that's going to be. But if he's able to turn it completely on and completely off, I think that will work. And then it's got the added advantage, you hook this up directly up to your battery system. And the only other thing, let's see, what was everything? Oh, the fact that it does not have adjustable current. So if you wanted to, you could probably play with the resistors on here and back the current off if you don't want, because otherwise I think it comes out of the box, it's set at 350 milliamps, which is what the all of the 1 watt LEDs say they want 350 milliamps. So here they just simply set it to that. And then if you want it dimmer than that, you can run the PWM to do it. But I won't know until the stuff shows up, and we'll have to, it'll probably be a week or two before I get these and try them out. And hopefully, getting close to the board is not going to screw this one up like the other one's doing. So those are on order, but I don't have those yet. And I can't think there's anything else about this. So anyway, we'll leave it at that. Those are on order, and that's a different option. So then I was saying, you could just, you look at these modules, you can get, like 10 or 20 different versions of this, but they're cheap enough. These are what, 6-pack for, I think I just bought some of these. It was odd because I had two boards that looked the same. They're blue and they got the same parts. And one was like 3/4 the size of the other one. I didn't realize that I had two different sizes of these boards, but apparently I do. Then they have another one. It's a red board that's got a different chip, and it'll put out 5 amps on the thing. So it's again, you got lots of different options of stuff you can buy there. And what was my other picture I had here? So then I was saying last week, I don't know if we did it on the recording or just off recording. I was saying I wanted to keep track of my refrigerator to see when the compressor is running on it, so I can plot that out and then go adjust the temperature and try to get it down to the point where it'll keep stuff cold and not freeze stuff and not be warm enough that I lose food in it. So I ordered this thing. I found various articles on YouTube where you go through, and one place they're taking one of those little Hall effect current sensors. I've got a couple of them on my robot here, one to measure my main motor power and one to measure the giant RC servo power. But it's basically just a little chip. It's got an input lead and an output lead, and it's really just a chunk of metal between those two, because so it's got like 2 milliohms or something of resistance there, because it really is just a piece of wire. And they've got a Hall effect sensor glued to that inside, so it's looking for the current flow around that object you got there. And if you look at them, they say there's something like 1500 volts isolation between the input and the output. So people are taking those and hooking them up to their, just cut their extension cord and solder this thing in line with that. And then you can measure the analog from that, hook it up to a microcontroller. So if I just want to know if the compressor is running or not, that would work. And then I found this board, and it puts out all kinds of stuff. Let's see, they give me pictures here. And there's tons of videos on this too, that you basically just hook this up to a microcontroller, and it gives you it gives you things like the AC voltage and the current and power factor and the frequency. And I can't think what else is here. And it will accumulate watt hours. So you can go ahead and send it a command saying, reset the watt hour indicator to 0. And then over time, it just apparently that just increases while the thing is running. Now, what I found was I went to order this and everybody said, "Oh, get the version 3 board." But when they advertise it here, it just says PZ or PZ, as they say, PZEM-04T, and there's no version listed. So you look at the whole thing here. They might say in here in some of the description, they might say it's version 3. And if you go zoom in on the picture here, let's see, how do I do this? And again, if I pull up the right images, if you look right here on the board, it says it's got the part number and this is V3. So I thought, okay, they're not saying it's a version 3, but that's again on Amazon listing. You can't trust it, but it was showing. This would show it. Anyway, right here it says V3 on this board. So I thought, well, I'm going to take the chance because it was like $5 cheaper than the next one that I found. And when it showed up, it turns out the board didn't look like this. It doesn't have this giant yellow capacitor. And down here, instead of these two opto isolators, it's got a single opto isolator. I thought, well, maybe it's the original version 1 that I've never seen documented anywhere. So I pulled up my magnifying glass and looked at this down here. It turns out it's a version 4 board. So it's a brand new board that they just came out with, and you look for information. I can't find any information, so I'm making the assumption it'll run with the version 3 code, so I can just write up some code and use the library for the version 3, and it should work. So it's just a matter of let's see, they show pictures here. No, they're not show it. Well, say it comes with this current transformer too. So what you do is you take like an extension cord and you strip back all the insulation, because this transformer has to go over a single wire of that. In order to get this one on, you're going to have to actually cut the wire, put the transformer on, and solder the wires back together, or somehow hook them back together. And then you have to get the AC from the hot and the neutral and hook them up. So on the connector out here. Come on, show me this. Anyway, on this 4-pin terminal, I think the 2 on this end go to the current transformer, and then these 2, one goes to hot, one goes to neutral, and that's your connections you need on the AC. And that would allow me to say unplug the cord from my refrigerator or whatever I want to check, plug my extension cord into the wall, and then plug the appliance into the other end of my extension cord, and then this thing will monitor everything going on there. And on the side, just got a like a TTL level serial interface. And there's examples for everything. So I can find code for an ESP32, or code for an Arduino, or code for a Raspberry Pi. So I was thinking I'd take my old original Raspberry Pis, which I found my whole box of Raspberry Pis when I was over in my storage digging around. So I have those now. So I could take one of those boards I'll never use for anything else anyway, and use it, dedicate it to this thing. And that way I can either write values to my SD flash card that's on it, or let it connect to my Wi-Fi, and I can send the number somewhere else. So that's just one more project that I'll probably never get around to. I'll put this up. I'll have to check my list of the things I'm never going to do, so I can go to my box of parts that I'm never going to use, and then I'll know where all that stuff's at. So that's something else I got was that. And as I said, I've got 2 different videos that they were talking about those driving LEDs. And somebody's coming right out and saying, well, is this efficient? And he says, oh, it's much more efficient just using a resistor and a MOSFET like I was doing. And I haven't run the numbers yet. Now that I've got it set up on the bench, I can say, I can take the input voltage and the current, and say how much power is that, and then look at it, the LED. I know I know it's going to be, say, 300. I was running 280 milliamps, simply because it was almost impossible to adjust that pot. I cranked it up and got that number and thought, okay, I'll just leave it there to play with. So it was, close to 300 milliamps. But at that point, I could calculate through all the way through on that one and know what the efficiency is on these little boards that I've got. And then if I want to know, taking that switching converter board and powering the modules from that, I can go through, because the easy way on that, being a switching converter, I need to go to the power supply and say, what's the voltage and current there, and calculate power, and then say, look at the output and say, what's the voltage and current, and calculate that to tell me what the efficiency of that is. But I'm sure, any of these things I do are going to be better than just the giant resistor, the MOSFET that I currently have in the thing, which does work just fine, but it's wasted a lot of power by doing that. So you have to have giant resistors so they don't burn up on you, and It's taking power. You're wasting power that you don't need to. So that was the point on that. And just looking around here at my other stuff on the table. Oh, I was gonna, since I had my solder there, and I was gonna do that RC servo and power driver experiment, but I see I didn't do that. So that again is back on my list of, I'll put it on my list of things I might do someday. So with that, I guess I'm going to say I'm done with that. And while somebody else is talking, I'll go to YouTube and see if I can find those two videos. And if I don't find them right now for the meeting, then I'll put them on the description. So they're actually on my other computer if I run across the room and look them up. But so I I'm done talking, and we'll turn it over to Al.
Yeah, I just looked up the power controller thingy that I bought, and I don't know that this is going to work worse or better than what you bought. But I've
So
got
you do have those?
no, they're on their way. So
Okay. Because I've got a
the,
video on those too, and somebody's drawn out the schematic for these things, and it turns out I think this one has a knob. This is you can either buy it this way. This is called the miniature version, the micro version or something, and you can get another one that's got all the parts on one side. Because if you go down the thing on the left there, if they show you the back of the board, it's got parts on the front and the back of this
yeah,
one.
they're not very good on pictures over here. That they're all the same except for their advertising.
Yeah, if you go searching, this shows up, 20 or 30 times, and you can get, somebody else will show you different pictures. But anyway, this one I think has parts on the front and the back. I was thinking this one has a potentiometer to set the current, but then it's something funny because if you pull up the schematic, which I found in somebody's comments at the bottom, they'd drawn the thing out, and they got the PWM directly overrides your potentiometer. So you can't go in and set the current with your pot and then do PWM to get a percentage of that. And so somebody was making a comment. So if you're going to run PWM, there's a resistor on the board. It's called the RWS feedback resistor or something. They're saying you can pop that off with your soldering iron and put on the value you want. So the thing will actually generate, the, at full on with the PWM, you can set the current by doing that. So,
Hmm.
so we'll have to see how that works out.
Yeah, it sounds like more DIY than I was expecting, but
Yeah, so it turns out this was on my list. I looked at this, and I was looking at the bigger board because I didn't realize they had these little ones at first. Then later I found out, oh, they sell it both ways. So it's smaller, but they just put parts on the back of the board. And I was looking at that and thought, well, I don't really want to mess with that extra PWM stuff right now because it doesn't do what I expected it to do. Whereas these two boards that I've got, the one I've got and the one on order, it looks like those will do what I want them to. So I think they'd be more predictable, but it's going to take some more experimentation before I can say they either work or don't work.
the other thing I put out a video, and Bob, are you still with us?
Oh yeah.
Um, make that smaller. So I can,
You make that bigger?
yeah, on its way.
Okay.
There you go.
So I won't make you listen to the video again, but so this was my board. Trying to keep up with Bob, I bought one of those 16 channel servo controllers. It was harder for me than I should have been, but I got this to work, and I got another 5 volt, 12 volt to 5 volt power converter to drive the power going into this. Part of the reason that this was hard was I had a servo that wasn't working, and I'm like, what am I doing wrong here? I can't get this to work. Um, and then by chance I said, well, maybe I'll try a different servo, and thinking there was something going on there. And so I got it to work. Got two servos sitting here. I'll show you another angle of that. Part of, because this is running Ubuntu and no machine in Ubuntu, and the RPIs are a little bit persnickety, I had to get this HDMI dummy fixture and put that on there. So that's a little wonky the way that it's sitting there, but it's what
Oh,
I got
those
for
are
the
called a
moment.
dummy plug if you go to order those or search for them. It's an HDMI dummy plug.
And
And
then
what's
you can
the purpose of that?
ask that question again.
What's the purpose of the dummy?
So that I can use, so this is no machine that I'm going to bring up,
Right.
and no machine would not give me access to the graphic user interface of the RPI unless I had a monitor hooked up to it or I had that dummy hooked up to it. It's
Oh,
um, something about it. If there's no HDMI hooked up, it bypasses some code, and no machine needs that code in order to like
okay.
access the computer.
And what that plug does, it just fakes it out. So it thinks there's a monitor plugged in. It has some it represents some kind of high resolution monitor. It's got HDMI goes back and forth, says what kind of monitor do I have, what's the resolution and all that stuff. And for some reason on the Ubuntu, when it comes up, it says, oh, I didn't find an HDMI, so we'll say we don't have any video available. But if you plug that thing in, then it'll when it first comes up, then it says, oh, I've got a monitor, and that keeps everybody happy.
Okay.
And they're quite cheap. I think they're like, I bought a couple. They're like two for $3 or two for 10 or something, whatever they were.
Okay.
The other thing sitting here is my USB hub. It's currently powered by a wall wart. And so I'll have to go back to what I did before. And luckily this USB hub takes in 12 volts, and I have, powered it from my terminal block. But the reason I needed that is my fancy camera called an OAK camera needed more power than what I could get on the USB ports from the Raspberry Pi. So those are the new components. And the reason I needed that camera is, I'm hoping when I lose RTK, the robot will stop, and then I can take over manual operation via, remote access, or what's referred to as teleoperation. So in this video, I go through and explain what I just explained. There's the camera sitting on the table. And then this is the screen, running on the RPi, and that's why I needed no machine to work, and because I wanted to have the lowest latency possible. And to do that, I think I've concluded the way to have the lowest latency in the video is to run the video native on the RPi and then emulate the whole screen via no machine. So that's what the video looks like. What that looks like in practice is, this is me on this computer logged into the RPi from a Windows 10 machine using no machine. Just can't really see those servos very well with the lights. So this is definitely work in progress. The steering control, I think I want to move down here because I can't see the other presets. So I can either slide this or I can click a preset. And in the video, if I go back to the video, I'm gonna let that run for a second. Trying to get to that screen. Yeah, so I didn't look at this after I taped it. So what you're looking for is movement there, and then how fast does it take for it to show up here? And quite unscientifically, I've declared that it's about a half a second off.
Mm.
So you see the movement there.
Yep.
So anyway, that's what I'm up to. The only other thing, I've got a little window here. I call it my telemetry box. I would put some other stuff up here just so I could monitor some other pieces of data as things are going on. So that's what's going on in my world. Waiting for parts on my LED. Like I said, that power module. And so I haven't spent any more time on figuring out if I'm going to be able to use this. So yeah, that's what I'm up to.
Okay. There was something else I thought of I was going to say, and I forgot what it was, but I had to do something with links to something, but I can't remember what it was now. So I just now started searching for that video I said was out here, and I don't know what to look for. So we may just have to. I'll just put it out in the description. People can go watch it later. So that's all I got again. So
Over to you, Bob.
Okay, I didn't get much done, but my parts did come in. I've got a 1x4 Molex connector that's directional. So I hooked one up to the, I don't know what to call it, the tower or the droid, the box, big box. And I'm able to take that electronics module and switch it between the little robot and the Raspberry Pi. And I'll see if I can pull up some pictures. There's screen starting. And it's coming. Huh. Getting delayed. Screen broadcast. No, didn't work. Try again. Screen. Okay. Huh. No, not working today. Anyway, it's see if I can find something wrong here. It's just a simple 1x4 Molex that I can go from my module that contains the Raspberry Pi and to the drive motors, either on the little robot or the big one. Let's see, I'll take the iPad over and see what. There we go. So it's just a 1x4. So I've got the female or the sockets on my module. The let's see. I don't know. I got to come up with a name, but I can just take that whole package and literally set it on the little one, on the little robot, like this. If I can, there, and just plug it in like that. And I've got the same setup on the Jeep. So the only thing I'm changing is that whole electronics package. So I got to come up with a name to call it. Maybe a droid? I don't know.
Bob's Beast.
Huh?
Bob's Beast.
Yeah. But that's about, I did get a double pole, double throw switch here. And I came up with 2 power supplies. So that'll be the next project this week, is be able to have those power supplies going all the time. So all I have to do is connect an extension cord and have the best of both worlds.
I like using those connectors because invariably you need to take stuff off and work on it, and it makes it easier than
Yeah.
whatever, screw ties or whatever they call those, or
But man,
something
trying to
else.
put the terminals on was a pain without the proper tool.
I and so my fix to that was you can buy pre-crimped wires,
Oh,
and so I bought pre-crimped wires,
okay.
so they don't always match the exact color that you're going for, but
Yeah.
it's easier than that fight that I know that you just went through.
I think it took me a half hour just to do one pin, the very first one. Darn thing keeps rotating and spinning as you try and clamp down.
Show us a picture of the road so we can see what the progress is on the road.
Okay, just go over here. So right now they're covering up everything that they've buried. They're rebuilding the hill and then most of their equipment is down on the other end. They put in curb and gutter to the south, or off to the south there, and they're still hauling a lot of sand or fill to build up the right of ways. And I don't know if you can see it through all the trees, but that hill that you see is kind of misleading, because right at the very top of the hill, it suddenly drops off down maybe 20-30 feet, and that's where they're storing a lot of the equipment that aren't being used. On the weekends, we'll go over there and take a look around, and maybe I'll get some pictures and show it.
Like a beautiful day in Minnesota.
Oh yeah, it's really nice. We're trying to get caught up on last minute landscaping before hard weather comes in. But that's been most of what I've been doing, is helping Nancy with the landscaping. Can't do too much because my shoulder, but I can do some things.
Jeff, if you can hear us, I think we're done.
Yep. Well, maybe he's still looking for something.
I run over my other computer and I was trying to search for this stuff and nothing was showing up. So let me try this. NTK. Okay. Well, they didn't bring it right up either. So again, I might just have to go back and say, I'll put it on the description and people can go look it up. Go watch it at their leisure. What I need to do is put my two computers side by side, or maybe use that no machine software to log in, so I don't have to go run across the room to try to track that down. I should have been smart enough to have it looked up before the meeting started, but I didn't do that. It's still not showing up, so. I was trying to think if I had any videos on that chip that Al just ordered, and I don't know. If they turn up, I'll stick those on there too. And then just keep in mind you can get that either as a bigger board with all the parts on one side, or the one he ordered is a smaller one that's got parts on both sides. And I don't know if, from a usability standpoint, if it makes any difference or not, but oh, wait a minute. Wait, here's that video.
Because I'm not remembering what video I saw to make me order it. I didn't come up with it on my own out of the blue.
Okay, so I will post to chat. Do I have my chat open? Well, I'll force it. So put this here, paste that there. Okay, there's a link to that. And if I were to share my screen here, I'll just kind of go through and poke at this. So let's see, go here. And I say probably don't have the sound turned on, but anyway, here's what the video looks like. And then if I just kind of, and what he's got here at the bottom, here's the actual module we're talking about. And then over here to the left, he's got a high power LED on it. And this right here in the middle is that INA 219 voltage and current sensor. And then I think that's just, that looks like an ESP32 he's got. I think it was just to generate his PWM to make this work. But if we start going through here, there's a close-up. Here's that little board down here. And he's got a push button on it because he explains that he bought an LED that's got an extra, like a 6.8 ohm resistor soldered to the front of it. And that way, if he puts that in series, he can measure that voltage. So he does a good job about telling you, how this thing's actually working and how he's testing it. And he doesn't advance very fast. So there's the chip. And see, if you solder the pins in and stick that on a board like that, then the fact that it's got the heat sink on the back of this won't be blocked by putting glue on like I was thinking about doing. And you see, compared to that penny there, it's a pretty small board. There's the back of it with that heat sink on. So if you don't cover that up, you're gonna be better off. Or if you'd stick that down to, say, a piece of metal or something, you'd probably be even better off. Let's see if I can just do this. Well, here's a picture of his LED that he got. And it's got this extra resistor soldered on. So you can use that by measuring the voltage across that, you can tell what the current is going through the LED. And that becomes handy when he puts it up on his oscilloscope display. So he's saying, here's the schematic out of the data sheet, and there's really nothing there. You have to have the driver part and have a resistor to set the current. And up here, he says somehow if we had the video or the audio going here, he says, so if you want 180 milliamps, just put in right here, put in an 18K resistor. He says 100 milliamp 18K resistor instead of the pot and the resistor that's on the board. So theoretically, I could pull off either the pot or the resistor on my board and solder on whatever value I want, and it won't be so touchy like the problems I was having. And then let's see out here. So he's showing this is his setup. So here's his module that he's got. And then this up here in the upper left is INA 219. Check my video here. Yeah, okay, it's working. So here's that. So here's that INA 219, and that's measuring the current coming off his power supply. And then somewhere there he's measuring the voltage. Maybe that's doing the same thing. So he gets the current and the voltage. And then over here, he's showing where he's hooking probes up to it to measure various voltages. And by measuring across this resistor, you can tell how much current's going through the LED. And then he did something cute where he's got a push button on the board. So you push the button and it shorts out that resistor. So you're driving it directly. And he goes through it. He says, okay, now watch the currents and the voltages. When I push this, you can see them change on there. So just again, just the fact that the way he's got this set up. But here's what his screen looks like. So when he's running this whole thing on the left here, this is the screen from. He's got a cute little box that plugs into his PC that does it's some kind of just like a universal test box. And I didn't see what the price on it was. It doesn't look like it's really cheap, but anyway, this is something you have. Then he goes through and explains all these different waveforms on here. Some of them represent voltage and some represent currents. And he said this green line is a calculated one. So some of his software says, take this trace and this trace and divide by something. And that's what this green trace is. And so you can watch that as it runs. So over here on the right, this is just an inset box. So he's got some kind of software that's talking to his INA 219, and it pulls up. Here's the shut voltage. Somebody's got two voltages coming here. I'm not sure what that's for, but the one says bus voltage. That's the one as he turns his power supply up and down. You can watch that change. And load voltage. Well, he's got lots of things there that I didn't realize what it was. But anyway, the point is this thing goes out over some kind of interface. I think it's like an I2C interface. Maybe that's what his ESP32 is doing. It's just reading that stuff and then sends it back so he can display it on the screen. And down here is just a photograph of the thing running. So as he does his things, you can see that light gets brighter and dimmer. And as he turns knobs, you can watch that. And he'll go through and then out here somewhere, he gets all the way out here and he said, okay, so it works just great. And then down here somewhere, like maybe here's a section called PWM control. So what it does, see you have this, let me just back up a little bit here. So right here, this orange line on there is showing his current that the thing is running at. And then when he says, okay, we turn on the PWM, and it looks like this. So it actually, he's putting in a 10% PWM. So it's on 10% of the time and off the rest of the time. And he was pointing out, it's got the slow roll off, but I looked at it and said, well, I don't care if it's doing that. So it looks like this is what I want it to do. You can turn the knob to run the current up and down. And then when you put in the PWM, it goes from that value down to 0. So you can adjust 0 to 100% of whatever current you have set on there. And I'm thinking that other board that I ordered from China will let me do the same thing. And the one that Al has, it does not work that way. And I thought of a couple ways around that. So maybe we can discuss that later when we get that far to see what to do about that. But anyway, he's got a real good video here, and just the fact that he's got it well planned out, and then he goes through and shows actual stuff running, so that's a handy thing to have. So I'll put that in the put that out. And then the other one, of course, I won't be able to find that one either. I can't even think what that one's called. So I'll have to I'll put that one in later. And the thing was, the guy wasn't quite as elaborate in his setup as this. And that's the one where I said he took his tweezers and shorted out 2 pins, and he hooked up a battery to prove that the PWM is being created like an on-off signal. He showed that worked, but it was, just more stuff of somebody actually hooking this stuff up and using it. I ran across this other one. It's called RoboJax, I think. ROBOJAX. I think is what the channel is called. And this guy basically just goes out to Amazon and buys all these little modules and it does a video on them. So that's one way to get, you get a module from eBay or Amazon, has absolutely no documentation. This guy has taken these things and gone through and shows you how to hook them up. And he does a little bit of analysis, and I was disappointed that the stuff he should have been analyzing, that was on that oh, I don't have it handy here, that MOSFET switch thing that I bought that I was showing last time. And he didn't catch the fact that, oh, by the way, it's wrong what they did. And he didn't tell you that, but he says, hook it up like this. Boy, it just worked great. So that one, if I think about it, I'll put that link on the description too. And just with the comment that, here's lots of examples of Amazon modules. And I don't think that's the guy that was doing this other intermediate video, one with the tweezers. I don't think that was the same guy doing that. So I'll try to put out at least 3 links so you can go look at that kind of stuff. And that's pretty much the end of that, I guess. So let's do stop share. Okay, so back to my stuff. I'll continue playing with this board I've got and see if I can get that. I just need to hook up, like, say, an Arduino or something to generate a PWM, and then see if it does indeed act like I expect it to, and then I guess I can go from there on that.
I'm all set.
One other point, I was saying this little board, the one, this board, the one that I've got hooked up, it takes a 2.9 to 6 volt input. And what that means is you can't put various LEDs in series, because if you do, your voltage on the LEDs becomes high enough that it won't work anymore. So what you have to do, you have to put your LEDs in parallel. So I could theoretically put, so right now I've got two in parallel just plugged in. I've got a red one and an orange one plugged in because they both run on the same voltage. And what that means is that when you do that, each LED will get half the current. So theoretically, I'd come back to the pot here and crank up double the current and get everything to work again. But if you get the one that's the switching regulator type, like the one that Al ordered, or these other ones I ordered from China, it can put out up to whatever your battery voltage is. So now you can put various LEDs in series. Because each time you put them in series, it gets higher. Like, for instance, here's this happens to be a 10-watt white LED. And if you look inside, it's actually got 9 LEDs. So it's got 3 strings of 3 LEDs in series. And when you do that, now you have to put at least 9 volts across this to get it to even light up. And that's just, as you start playing with the series parallel combinations, that's just what you run into. But if you get the ones that have the direct switching converter, so you can put in, say, 12 to 14 volts, and then convert that down to the voltage and current required to run the thing. So theoretically, I could run this 10-watt LED by doing that same technique, just plugging that in and set the current on the board to whatever I want. Say, all right, you can see I had one angle there. You could see the 9 LEDs in there. They're just spaced out. There we go. You can almost see them there. So anyway, that's another thing. If you need even more intensity, you can go with something like that. So, and as a point of reference on that, the light bulbs in my bathroom, that's those cute little filament lights that everybody thought was interesting. But you look at those and it says it's a 60-watt replacement, but it says the LED is actually 4.5-watt LED that's in there. And then this little thing here says it's 10 watts. So this is theoretically puts out, well, it takes twice as much power to run it. Now you'd have to look up the spec sheet and see how many lumens it puts out. The small ones, they rate them in millicandela, and they get bigger, they might rate them in candela, and then they switch over to lumens as what they call the luminous intensity or luminous flux or something, and they call it lumens. And like a standard, what is it, 60-watt incandescent bulb, I think it puts out like 800 lumens. So you'd have to compare that to, say, one of these. If you look it up in the chart, it'll tell you how many lumens it puts out. And so that way you can say, well, I've got a 60-watt light bulb that gets really damn hot, and you can't buy them anymore because they're so inefficient. So that's one way you can compare the stuff too, is look at other things that are out there, and just to see, just to get an estimate of what it's going to do when you hook them up. Oh, I was going to ask Al. So your plan was you want to put a single blue LED, or you want to have multiple blue LEDs, or you just want to have RGB with one or more LEDs on the thing?
Well, uh, one blue LED and take the innards out of this and put, a blue, green, yellow, red individual LED into this. Basically strip out the guts and use the lenses on this.
Okay, so I just wondered if you thought far enough ahead to know, are you going to be putting the LEDs in series or in parallel, or if you just have one per color, then I guess that's a moot point because you're not going to be connecting multiple ones together. So,
At the moment, I guess I was thinking one per color.
okay. If you just do one per color, then you could go with the 10-watt ones. And I have no idea, I haven't, tried that to find out. I guess you could set up a little test bench, take like a battery, and then on top of it, put your different types of LEDs, and then lay it out in the sun. See, I could take it out in my yard and look out my window here at it, when the sun's out, and see which types I can see and which ones I can't see. So that might tell people more too, to do that.
Yeah, the darn 1 watt, just connecting it to the desktop power. I'm like, holy cow, that is blinding. I mean, it's dangerously blinding.
Yeah. But when I got mine all set up and it said it was running 290 milliamps through it, I thought, I expect this to be brighter. Of course, I had it pointed away from me at the time, so it was lighting up my whole desktop. So a lot of the stuff is just deceptive. Until you actually just put it out in the sunlight and look right into it and say, "Can I see it?" That's going to be the real trick right there. So.
You're right on that.
And speaking of those lenses, you've got the multicolored lenses on that thing you had right there. A long time ago, I went out just looking on Amazon to say, can I get a plastic, some kind of a plastic lens that I put over the top of an LED, and you get like what do you call it, the faceted surfaces on that makes it diffuses it more. I couldn't find anywhere I could just buy, for a couple bucks, get a piece of plastic you put over it and have it do that. So I was noticed that when I just at the grocery store, they got the self checkout out, and then up on the top they got some kind of a light that flashes red or green depending what's going on. And I
Mhm.
thought, well, those would work great, but I don't want to have to go out and buy one of those for being an industrial device. They're going to want a fortune to get something like that.
Yeah, and
So
the
if anybody,
grocery store probably doesn't want you to take theirs apart either. So
probably not. The other thing I thought of, since I just had a one of my normal LED bulbs go bad in my floor lamp, they've got, depending which ones you get, I think they're probably all plastic. So it's going to have like a frosted plastic dome that's glued onto the top of it. And you might be able to take that. So if I take one of my 10-watt LEDs and put this dome over the top of it, that might be another way to do that. So that's something else I could play with if I get that far. And then speaking of that LED that LED light that I just replaced, I was sitting there and all of a sudden I noticed the light in the room started acting stupid. Oh, my power's going off, and I realized no, it's just that LED bulb is starting to flash and do funny things. And I took it out to replace it. I noticed it's really heavy, so that one's probably got a transformer in it. And the one I replaced it with weighed almost nothing, so it probably has, almost no electronics in the thing. So I found that interesting too. And I've never seen a write up on, the efficiency between the two types. I suppose I could measure it myself if I really wanted to, but that's just another thing that popped up, and just happened to be, it wasn't really related to what I'm doing right now, but it got me thinking about it, that yeah, you could go measure all that stuff and find out, how good these different types of LEDs are, or
well,
different
for
types of
what it's
lights
worth,
are.
the $25 and-on light that's not bright enough for outside, these lenses do. You can get them apart,
Okay.
but you don't have a top, so they're solid. It's just the circular part.
Yeah. And in fact, sometimes they'll do that and they'll have like a chrome plated or some kind of a mirrored thing. So you've had a mirror, like a cone that you put in from the top, and then you put your light underneath, so the light would then reflect off that cone and, be directed out the sides. So that just, if you go to Dollar Tree, and they got those little 99-cent yard lights that you put out. So it's got the solar cell on the top. It's got an LED in it. Those will have that fancy mirrored stuff in those. That might be another way to do that. You suppose you take one of those lights and pull out the cheap little LED and put in a big high power LED. That might be a way to make it work too. So just more brainstorming on that kind of stuff.
I like your thinking. That's it for me.
Yep, me too.
I guess that's it for me. So let's see if I can hit the right button this time. I'm going to hit stop recording as opposed to ending the meeting. So we'll see what this does.